Hello, we are back with Quartic surfaces part 2. This is going to be, I think, pretty short lesson. There's not really much to look at other than nothing new other than 1-sheet and 2-sheet hyperboloids. So yeah, we're going to start with that. So earlier we looked at hyperbolic traces. And we also had one that was an equation of a cone, like two double cones. You can see them right here. Stuff that look like this. We're going to be expanding on this formula where this is no longer 0. So generally, this form is going to look like this: x squared plus y squared minus z squared equals some constant squared. And for, I guess, like an exam tip is sometimes they'll play around with these signs to confuse you. The standard form that I keep in my head is that two of the variables that are squared have positives attached to them. So here it would be the x and the y. And then one of them is negative. And then this constant could either be positive, which I guess maybe squared isn't the right way to, we'll just say it's a constant. Sometimes this constant can be positive or negative, depending on the problem. But where all the variables are squared, you're going to have two that are the same sign, and they should both be positive for standard form, and then one that's going to be negative. So here it's the z squared. So if we look at, we'll start with a 1-sheet, and then we'll look at a 2-sheet, and we'll decipher why it's called that way. So first we'll get into an example. Say you have, we'll just start with something really easy. X squared plus y squared minus z squared is just 1. So if you look at we talked about traces last time. So a key trace for this one would be looking at the xy trace. So that's when z is 0. So then you're going to get x squared plus y squared equals 1. So that's our xy trace. So this is a circle of radius 1. Okay. Notice the difference between this, where it's 1, and earlier when we had the cone example that looked like this, equals 0. Here the xy trace had, so if we eliminate this, we had x squared plus y squared equals 0. That's a circle of radius 0. So this wasn't a circle of some actual radius. It was just a point here at the origin, but that's not the case now. The rest is really just going to be the same. I guess we could observe the hyperbolic traces, but what's really going to happen is you're going to get a kind of hourglass shape that's like going out into these directions, like that, and like that. Same under as well. Right, and it's something, these like circular cross sections. I don't know, pretty sloppy drawing, but you can maybe, hopefully, see what I'm trying to get at. This is kind of what it looks like. So it's this hourglass shape, and then this is the radius of the xy trace circle we were talking about. So next, what if, okay, we could look at the hyperbolic traces, of course. If you look at like the xz or the yz trace, you're going to x squared minus z squared equals 1, or y squared minus z squared equals 1. And this is not going to have a trace. This is never going to intersect the z-axis, because if you said x or y is 0, right, you're going to get z squared equals -1, and that's just, there's no real number for that. for z in that scenario. So this is never going to intersect the z-axis, and therefore it's oriented along the z-axis. That's like where its center is. Okay, now we could move on to, so this is one sheet, okay? This is a one sheet hyperboloid. Okay, what about two sheet? Well, you could probably guess that instead of where this is positive number, it's going to be negative here. X squared plus y squared minus z squared equals some negative number. Okay? So what this is going to do, it's going to affect our xy trace. So if you look at our xy trace now, you're going to get x squared plus y squared equals -1. That's not possible. So at the xy plane, when z is 0, there's no trace. However, if you rearrange the equation, equals z squared minus 1, right? We just moved the z squared to the right side. When z squared is equal to 1, so z squared is equal to 1, then this whole side becomes 0, right? So what you're going to see is that this is actually at z equals 1 or -1, it's going to start to form something. Now, what if z squared is equal to like 5, right? Then you're going to get 4. You're going to get x squared plus y squared equals 4. So that's going to be equal to, that's a circle that has a radius of 2. So, I mean, root 5 is like a little greater than 2. We'll say that's like, I don't know, somewhere here. So up here and down here, you're going to have some kind of circle. So you see that in here, in this middle section, there's nothing. Because the very first point we get out of here is when z squared is equal to 1. So then you get x squared plus y squared is 0. And that's our first point on the z-axis. So it's going to form something like this. And then these circles are going to keep growing larger and larger as the value of z squared increases, right? And the reason this is called two-sheet hyperboloid is because, I mean, you could imagine like you have like some sheet of something and you want to cover this shape up. You can't quite cover these guys' surface area with one sheet. You need two sheets to cover this guy up, and then you need another you need one sheet to cover this guy up, and then you need another like sheet of some surface area to cover that guy up. But up here, we could get some really large sheet and cover this whole guy up. So this is one sheet, this is two sheet. And then if you want, you could see a better visual over here. So you see there's like a separation right here. And again, you can look at the hyperbolic. So like this is the, let's see, this is the xz plane. There's a hyperbola right here. There's also a hyperbola right here, right? And there's also a hyperbola in the, like a disconnected hyperbola in the yz plane, because you have that negative number. But in these kinds of problems, personally, I don't really want to look at each kind of trace and look at hyperbolas. I think hyperbolas are really messy to work with, so I don't like looking at them very like intuitively. I just kind of scout out for, again, two of them, I want them to share a positive sign, and then this one I want it to be negative, or the opposite sign, and then based on what the constant on the right is, I could determine fully what it is. If you have the left side in this form, and the right side is negative, then I know it's 2-sheet immediately. If I have this form and the right side is positive, then I know immediately that it's 1-sheet hyperboloid. If I have this same exact thing, but this is 0, then this is going to be a cone. So I just go off of it like that. Okay, I guess you could play around with this a little bit. You could also have something that's like this: 9x squared plus y squared minus z squared equals -16. So just by the looks of it, we could apply our rule where we say, okay, let's look at the left side. So we have an x squared term, a y squared term, and a z squared term. These two are positive. This one's negative. So this left side is in our standard form of x squared plus positive y squared minus z squared. And then this right side is negative. So it's a negative value of k. So we know that this is going to be 2-sheet. Now on the test, they might have maybe the answer choice might be like 2-sheet elliptical hyperboloid. This is elliptical because when, so let's see, if you move this around, plus y squared equals z squared minus 16, right? Say z squared is greater than 16, then you're going to have 9x squared plus y squared equals some positive value. And now you're, so we know this is 2-sheet, remember. So that means there's no trace when z is 0, because this is negative. But whenever we do develop some kind of value for a certain value of z, so picture we're like somewhere, this is the origin, we know there's nothing here, up until some point where z squared is equal to 16, and then past that, we're forming some kind of shape. Now, what is this shape? Is it a circle? No, it's an ellipse, because you're gonna have 9x squared plus y squared equals some value of k, positive k. So this is just 3x squared plus y squared equals k. And you could see that you could observe it's like where it intersects like what x values it's going to intersect, like a line or something. So here you're going to have y, if you say y equals 0, then you have 9x squared equals k. So x is going to equal root k over 3. That's going to be its, well, plus or minus root k over 3 is going to be its x-intercept, and then its y-intercept is going to be just root k, plus or minus root k. So you're going to, if you look at it from the top, you're going to have some like value up here, and then you're going to have something like that. If this is your y, or sorry, if this is your x and then this is your y-axis, it'll look something like that, right? So this would be like an elliptical 2-sheet hyperboloid. So yeah. What about if we had negative x squared minus y squared plus 9z squared equals 1? So this guy, yeah, I mean, you have to remember that we want them in standard form. So we want two of the variables to be positive, which isn't the case right now. We have a negative x and a negative y and a positive z term. So if we factor out a negative, or I guess we multiply both sides by -1, you'll get this. Oops. So this is, we could easily identify this as 2-sheet, and it's going to be elliptical. Sometimes on tests, they'll also do something where they want you to complete a square. So typically, it'll look something like, I don't know, x squared minus 6x, then plus y squared plus, or I guess, minus z squared equals 3. Now all this is going to change is it's going to move like the center of the hyperbola. And you could find where that is by just completing the square, and completing the square will develop a constant term that you could move to the other side and observe your new hyperbola. So if you complete the square here, you can get x minus 3 squared, right? Now if you square this out, you're going to get x squared. So this whole thing gives us x squared minus 6x plus 9. But we only want x squared minus 6x, so we're going to take this guy, subtract 9 from him. So subtracting this 9, it's going to turn this into x minus 3 squared plus y squared minus z squared. We're going to add this 9 to both sides, so this is going to give us 12. So this is two positive terms, two positive like variables, two positive squared variables, one negative one, so this is in standard form, and then positive on the right, so this should be one sheeted. And then if you want, we could plot this. So all this does is it's going to change the center of this xy trace, right? Because if z is 0, you have x minus 3 squared plus y squared equals 12. It's going to center it at 3, 0. And you're going to have this xy trace there. So let's see this. X minus 3 squared plus y squared minus z squared equals 12. And then let's plot out the center. So 3, 0. Yep. So there are our equations. And then this is the one-sheeted hyperboloid we've just found. So there's the center, that's at 3, 0. But yeah. Okay. Now I suppose we could move on to some practice problems. Yeah, like I said, this video wasn't going to be too long. We could actually, why don't we look at all of the shapes we've made so far. All of the 3D shapes you could expect to see like on an exam. So, I mean, first you have ellipsoids, which are just kind of changing like the equation of a sphere. So for a sphere, remember, it's just x squared plus y squared plus z squared equals 1. For an ellipsoid, it's going to be x over a squared plus y over b squared plus z over c squared equals some value. I don't know, 1, whatever. That's going to give you an ellipsoid if a, b, and c are not equal to each other. Paraboloids, you have z equals x squared, or x over a squared plus y over b squared. That's going to give you a paraboloid. So let's label these. So this is sphere, this is ellipsoid, this is a paraboloid. And now one sheet hyperboloids, you're going to have x squared over a squared plus y squared over b squared minus z squared, where c squared equals k, where k is greater than 0. So this is a one sheet hyperboloid. Two sheet, it's the same thing, but k is less than 0. And then for a cone, it's basically this, but k is equal to 0. And then a hyperbolic paraboloid is going to be z squared equals x squared over a squared minus y squared over b squared. So, yeah. Okay, so this is a hyperbolic paraboloid. Okay, now we could move on to some practice problems. Okay. So, first question, this is from Spring 2023, Exam 1, Question 4. So it gives you this equation. It says 2x squared plus 3y squared equals 4x plus 2z squared. And it tells you to identify what this is. So my preferred, like how I would approach these is I would group terms. So if I grouped terms on one side, I have 2x squared minus 4x plus 3y squared, and then minus 2z squared. And that's going to equal 0. Now we're going to have to complete the square. I do complete the square in a kind of weird way, I think. So just complete it however you want, but I'm going to explain how I do it. So to me, it makes sense that I factor out this 2. So I'm going to have 2x squared minus 2x. And then this is going to equal 2 times, if I complete the square on this guy, I'm going to have x minus 1 squared. And then this is going to produce a plus 2. So I want to subtract the 2. And now that should give us x squared minus 4x. I mean, let's see. So this is our completed term, just to make sure that we don't make any sillies. X squared minus x. Yeah, that's minus 2x, and then plus, plus 1. It's going to be plus 1, so I almost tried to, because this should be minus 1. This should be plus 1, and then subtract a 1. These cancel, and then you distribute, you're going to get 2x squared minus 4x, which is what we started with. So this is good. This is good. So we're going to, and then we could distribute this 2 in. So you're going to get 2 times x minus 1 squared minus 2. Then you're going to have plus 3y squared minus 2z squared equals 0. You can move this 2 to the other side. Plus 3y squared minus 2z squared equals 2. And that's what we're going to use to find our answer. This is what we started with, and we changed it to this, literally just by completing a single square. So let's apply our rule. We know that if we have two things that are positive, two variables that are positive, and we get a positive on the right, so plus k, right? This is standard form. Does this match standard form? It does. The z is negative, or one of them is negative, and then two of the variables are positive. So all of these are attached to the x, all of these are attached to the y, and then you get a positive value. So this should be one-sheeted hyperboloid, and that's answered choice D on the in the exam, which is, yeah, that's right. So yeah, I mean, I just think of it like I simplify it to this kind of form, and I look at whatever's attached to each variable, if the signs add up, and that's what I do to get my answer. Okay, next one is from the fall 2024 final. It tells you, it gives you this. This is actually kind of annoying to do. This one has quite a few. Complete the squares. Okay. So, yeah, I mean, luckily for us, this is what they give us, and they want us to identify what this is. Luckily, they already grouped up the terms. We have the x's with the x, y with the y, z with the z. I like just keeping this as a variable squared, this guy, so I'm going to factor out a negative. This guy will keep him as is, but just to clean it up, we're going to put them in parentheses. And here we're going to factor out another negative. Okay, and now we could start completing the square. So here you're going to get negative, let's see, x minus 3 squared, right? X squared minus 3x minus another 3x, that's going to be the minus 6x, and then you're going to have plus 9, but we don't want a plus 9, so we're going to subtract a 9. This guy, that should be y minus 5 squared, right? You get y squared times, or minus 5y minus another 5y, that's our minus 10y, and then plus 25. But we don't want the plus 25, so we're going to subtract the 25. And then here you're going to have z minus 4 squared, because that's going to go as z squared minus 8z plus 16. But we don't want plus 16. We only want the rest of it, so we're going to subtract the 16. That's going to equal 1. Now, you could see what's about to happen. This guy is going to become like I'm not going to rewrite the whole thing, but you're going to see once you distribute the negative, you're going to get a plus 9 here. This guy is going to give you a minus 25, and this guy is going to give you a plus 16. So all these constants are going to cancel out, right? But now if we distribute the negatives, we're going to have negative x minus 3 squared, and then you're going to have plus y minus 5 squared, then minus z minus 4 squared, and this is going to equal 1. Okay, now does this match our standard form of x squared plus y squared, or minus z squared equal some, okay, well here it's positive. It does not. It does not, because here we have two variables that share a positive sign, but here we have two variables that share a negative sign. So if we multiply both sides by a negative, we're going to turn it into this, minus y minus 5 squared plus z minus 4 squared equals negative 1, okay? So now we have two that share a positive, that's x and z. We have one that's negative, this y term, right? And then, so this is in our standard form, but the right side is negative, so that tells us it's two-sheeted, and that's option choice D again, which is right. Okay. And then we have one more question. This one's from Exam 1 in Fall 2023, question 10. So it's also just identify what the surface is. The equation they give you is x squared minus y squared minus 4x plus z squared equals 4, right? We have to do a bit of rearranging to group up our variables. X squared minus 4x minus y squared plus z squared equals 4. You could see from this point that all you have to do is complete the square on this term right here. The other ones look chill. There's nothing else that shares a y or a z. So if you complete the square over here, you're going to get x minus 2 squared. That's going to, so right now this is going to give you x squared minus 4x plus 4. We don't want a 4. So we're going to subtract a 4. Then minus y squared plus z squared equals 4. If we put the 4 to both sides, you're going to get plus z squared equals 8. Now we have all our terms figured out. Now we just look at our standard form where we want two that share a positive sign and then one that's a negative sign. So we have this x term right here that has a positive. This z also has a positive. So this guy is the odd one out. So that side is in standard form. The right side, that's positive, so that immediately tells us it's going to be one-sheeted, a one-sheeted hyperboloid. So that's option choice B. The other option choices are ellipsoid, hyperboloid of 2 sheets, a cone, and a hyperbolic paraboloid. So, I mean, we could easily tell that this isn't an ellipsoid, because an ellipsoid would have all positives on this side, and these coefficients over here wouldn't be the same, but they are. So if this was positive, then this would actually be a sphere, not even an ellipsoid then. It's not a hyperboloid of 2 sheets, because this 8 isn't negative. It's not a cone, because this 8 isn't equal to 0. It would be a cone if this was 0, but it's not. And then it's not a hyperbolic paraboloid, because for a hyperbolic paraboloid, this guy would have to be 0. And that's not the case here. So yeah. Okay, I think that concludes today's video. Thank you for watching, and please leave comments.